Good morning. I am Madhup Agrawal, Assistant Professor in IT Department at AKGEC, Ghaziabad. Today our topic is recursion. This is main topic of programming and very useful topic, recursion. So, what is recursion? We simply say that recursion is a method of solving a problem where the solution depends on the solution to the smaller instance of the same problem. Means we break a big problem into similar kind of a small problem and solve our problem accurately. So, we can say by using an example, we know the factorial of number. What is the factorial of a number? Factorial of a number is we say factorial of n. Factorial of n equal, this is 1 when n equal 1, when the value is 1. Otherwise, the factorial of n is n into factorial of n minus 1. Means we are solving the factorial, and this is the main problem, to solve the factorial n, and we break this problem into similar kind of problem. Here also this is factorial n minus 1. Okay. So, we are breaking here a big problem into similar kind of a smaller problem until n reach to the value 0. Okay. If n equal 0, then factorial of n will be 1. This is the basic concept of recursion, which is applied in the mathematics also, and our task is to convert this problem into programming. So, how to convert this into programming means how to implement the recursion in programming. So, in programming, recursion technique is implemented by function or prototype. We all know the function. So, with the help of function we implement the recursion. Means when a function call itself from their own code is known as recursion. Function call itself means here factorial n, as we already seen, this is in mathematics factorial n, and in programming this symbol, just like we write a name factorial and we pass the argument n. So, we are using the function in simple form. This is the base condition, n equal 0, then the value of factorial is 1, and otherwise the factorial of n is n into factorial of n minus 1, means sub problem statement. Here is also a function. When a function call itself, this function uses same function with a different parameter, here n and here n minus 1, approaching towards the n equal 0. This is the base case, we generally say. So, in programming we simply convert this logic into our syntax of programming. Here we are using the Python language to convert our code. So, we say simple factorial n, use the def keyword, and factorial n similar, and if this is the base case, first we check the value of n is 1 or not, means reach base case or not. Value of n is 0, then return 1. So, value of n is 0, then we will return the 1. Otherwise means simply convert into syntax of the Python else part. Else what we get? Else we return n into factorial n minus 1, simple, return n into here fact, and the parameter is n minus 1. So, we are simply converting this into a particular language syntax. Here we are using Python, so we are converting it into Python. Otherwise we can also change into other language if we want to change into C or C++, same concept is there. So this is known as the base case, as we already discussed. Base case is n equals 0 then return 1, and this is a recursive call. This is a recursive call when a function call itself known as recursion. So here same function fact already calling itself same function fact with the different parameter. So this is a recursive call here. Now we can take the examples how recursion works for different situations, different problems. Here is the program to calculate the factorial of a number using recursion, same problem here. Now the complete program of recursion, we already make this program, this function else return n into factorial n minus 1, the complete. Now the driver code we simply collect the input from the user, collect the input, enter a number, and we get the number entered by user in the variable num. We gave the name num, and we pass this num into the function. We are calling the function fact. We are calling the function fact. Then control goes from here to this function, and the value passes from num to this particular variable n. And after calculation this particular result, we are passing n value, just guess a simple value, that is means 4. Then this will return, this will calculate 4, this is true or false, this is false. Then control goes to else part, then this will return 4 into, this will return 4 into fact, this become 3. Then again this will call a recursive method or function, this is 3 into fact 2, and again this will call 2 into fact 1, and then it will call the 1 into means fact 0. Now this, when this will call, this condition will match, and then this will return 1, this will return 1. Okay, again this will return 1, then the overall calculation is 1, and this will return 1 here, and overall calculation become 2, this value of 2 comes here, and overall value is 3 into 2 equals 6, and this particular 6 written here. Then 4 into 6 equal 24, and this will return to its calling function. First time we are calling here, then we will get the 24 here, and this will assign to this particular variable f, and we are printing factorial of num, means num, we just guess num, the value was num was 4. So the factorial of 4 equal f, means this is 24. Okay, so this is a recursive technique. Now move forward, just we get the output, enter number, and we get enter the number 4, and the factorial of 4 equal 24. Now the same flow we can show here also. The factorial 4 first time call from here, this point, again this will goes here, and 4 into fact 3 call, and next recursive call is 3 into fact 2, then recursive call, this is 2 into fact 1, then again recursive call 1 into fact 0, and then fact 0. Fact 0 is the base case. This is the base case, means to reach this point no recursion, recursive call will make another recursive call will make, and factorial 0, this will return 1, and after calculating 2 into 1, this will return 2, and this is 3 into 2, 6, and this 4 into 6, this will return 24, and then f will get the value 24 as a final value. So we can also, so here this is the first call, again 4 into 3, again fact 2, then fact 2 means this one, fact 1 means this one, then this will return 1, means complete calculation is this one, that is 24. Okay. So this is a simple approach as we use in mathematics. Now what are the contents of recursive function? As we see here, what are the content for this one, how to build a recursive call or recursive function. First is the base case. There must be the base case, means stopping condition must be there, otherwise a infinite recursive call and the program will not stop and we will not get the final value. So base case or base cases means there must be a single base case or multiple base cases, 1, 2, 3 and so on, but in much of the cases there are one base case, as in the previous example, means base case values of the input variable for which we perform no recursive call. No recursive call, these are known as a base case. There should be at least one base case. And second one, recursive calls, means just like we say here in the else part, call to the current function, same function will call, and each recursive call should be defined so that it makes progress toward the base case. This is the important point. Just in the previous example, the base case is this one and we are calling the recursive call here, recursive call here. So we are approaching after each recursive call towards the base case. If n equal 4, then this recursive call for 3 and again recursive call for 2, then 1, then means approaching to the base case, approaching to the base case. This is recursive call. Now take another example to clarify our concept more and more. Now just take example of a power b. We want to calculate the a power b. So what is the a power b? A power b is simply a into a b times. So we can say already this is a and this is n b minus 1 times, means a power b minus 1. Okay. This is the recursive method, means we are the solution, in the solution of a power b we are using the same sub problem, same type of sub problem, a power b minus 1. So this concept we will use for to solve this a power b through the recursion method. So a power b minus 1. So we can say a power b equal n to a power b minus 1 and a power b, this is the base case. If b equal 0 means power, if the power is 0 then the value will be 1, this is the base case, otherwise the a into a power b minus 1. Okay. So just convert this mathematical concept into programming. So first convert this a power b in the function form. We give the name my exponent and two parameters are there. First is a, second is exponent, that is b parameter, and we give the my exponent. So we write here my exponent, the value of my exponent a power b will be 1 if b equal 1. B means the exponent part is 0, then the value is 1, otherwise the a power b equal a into my exponent a and b minus 1, otherwise. Okay, just we are converting this into function format, just giving the name here and passing the parameter here separately. So in Python programming, we write the function by using def, give the name of the function my exp, my exponent, and parameter is ab, and ab place the colon. Okay, now the body part of this function, if b equal 1, first base case, this one we write this at this particular place. If b equal, for comparison we use in syntax double equal to sign for comparison and single equal to sign for assignment. So we follow the syntax of programming, we are using Python, so double equal to for comparison, so we compare b equal 0, then return what, give the value 1, we place this one here, return 1, otherwise means this else part, else means otherwise, means the condition is false, then what do, then do this one, then return this a into my exp a power b minus same. We are just giving the syntax of particular programming, means main part for to solve a problem using recursion, simply think on this one, think on this one, this is the main task, and we just convert into programming syntax. So first think about this mathematical definition, how to write in recursion. So the complete program for this one, now the driver code, this is the driver code. First we are demanding the base from the user, enter base, give the value, and we save in the variable named base. And second, enter exponent of the parameter from user, we save into exp, and then we call the function, our recursive function with this parameter base and exponent, we are passing 2 parameters, and these 2 parameter comes here in the a and b. Just guess, if the value of base is 4 and exp is 2 or something 2, then the value 4 and 2 will receive here and calculation perform on this. So the final, after calculating the exponent, we get the value in the val and we print base power exponent equal val, just like this one. Enter base equal to enter exponent is 4 and 2 power 4 equal 16. Okay, we can give any value 2, 4, 4, 2, 3, 2, 8, 11 and so on, any value, because this is user defined. And the flow for this recursive call, we can say first call is this one. Now this will call 2 into again call the different parameter. Now base is same and exponent is decreased by 1, because 1 is one value comes here, and again calling recursive call 2 into exponent 2 power 2, again decreasing, approaching to the base case, this is b and b is approaching, decreasing 1 by 1 and approach to the 0 value. Now 2 into 1 decreased, minus 1, and again this approaches to 0. Now 2 power 0, this is the base case, b is 0, then return what, return 2 power 0, return 1. So this will return 2 into 1 equal 2, then this will return 2 into 2 equal 4, then this will return 4 into 2, 8, and this will return 8 into 2, that is 16 here, and this 16 is saved in the variable p. So we get the final output. Where we get the final output? In the first recursive call. When we call the function, then we get the value, final value. From where we call the function, we get the final value. And another example we can take here, some difference means recursive call. In the previous two examples we get only one recursive call, but in this example we call two recursive call at the same time. So just example, Fibonacci series up to n term. And what is the Fibonacci series? This is a series 1 0, start from 0 and 1. These are the two terms, basic terms, two fundamental terms, and next term will be generated with the help of these previous terms, previous two terms, means 0 plus 1, 0 plus 1, this will generate 1. Then to generate the fourth term, we will use two previous terms, term number 2 and term number 3. The value of term number 2 is 1, value of term number 3 is 1. So 1 plus 1 equal 2, we get the 2. For the next term, term number 5, we use the term number 3, term number 4, means term number 3 value is 1, term number 4 value is 2. So we will get 2 plus 1 equal 3, and so on. We will get the value of a particular term. So Fibonacci of 1 equal 0 means this is the term number. Fibonacci of this particular term number is 0, this is fixed. Fibonacci of 2 second term is 1, this is fixed. Now Fibonacci of third term is 1, and so on. Fibonacci of sixth term equal Fibonacci of fifth term plus Fibonacci value of fourth term equal 3 plus 2 equal 5. Now what is the Fibonacci of n? So here two base cases. First is if n equal first term, then this is 0. If n equal 2, then this will be 1. Here two base cases are used. These are the base case, two base cases, and otherwise the Fibonacci of n equal Fibonacci of n minus 1 term and plus Fibonacci of n minus 2 term. So we will use this recursive call. Why this is recursive definition? Because we are using the same sub problem. We are breaking our original problem into the same type of sub problem. Same type of, here also Fibonacci we want to get the Fibonacci of n, and here we want to Fibonacci of n minus 1 and n minus 2, same type of sub problem. We break our original problem. So for conversion into Python code, similar, just follow the syntax and convert this mathematical definition into this particular language definition. Language is Python, so use the syntax of Python. Simply def, give the name of fib n, and then check the base cases, two base cases. First base case is this one, so simply write this is in the syntax of Python. If n equal 1 double equal to for comparison, then return what? Return 0. Else if the n equal 2, what we get? Return 1, simply return 1. Otherwise means else, return what? Return this one, simply. Else return this one, as we write here, just copy paste something here, but just follow the syntax of particular language. Okay, so this is the Fibonacci series. Now we say the complete program. This is a driver code. Enter the term of number of terms, how many terms we want to get, and we want to print the series. So this function used to calculate the value of a particular term number, this one. So, here enter the number of terms, we want to print the whole series for a particular terms. So, we get in the num and we use the function we use the looping concept to generate the different terms from term number 1 to term number n plus 1. Why n plus 1? Because this is excluded. Excluded means this will go from 1 to n, means num to m, and this is the jumping step, stride is 1. So, 1, then we will get 2, then we will get 3 up to num, and for each y we are calculating the value. So, for here we call the function phi y, and this will called, and we get the result. Just guess, enter the number of terms, we want to 6 terms. So, for the 6 terms we will get the output, this one. We can understand fib 4, fib 3 plus this is fib 2 recursive call. Then again fib 3 generate a recursive call, this is fib 2 plus fib 1. Now, fib 2 and fib 1 is the base case, we get the base case. So, for fib 1 we get the 0, 0 comes here, and fib 2 value of fib 2 is 1, base case, then base case return 1 and 2. So, here plus operation, here we get 1 plus 0, this is 1, we get the value of 1 here. So, this is get the 1, and again this is the base case, we get the 1 here. So, 1 and 1, 1 plus 1 equal 2. So, we get the 2 here. Fibonacci just as part we just for the value n is 4. Now, so these are the some examples to understand the recursion. Now, in programming, in machine, how to which data structure is used to implement the recursion. So, many programming language implement recursion by means of stack. Simply stack is used to implement the recursion in programming. The manner of stack is, what is the manner of stack? You already know stack. Stack means in the order of last in first out manner stack works. Last in first out means last element comes and firstly it will deleted from the queue, deleted from the stack, or we can say access from the stack or data structure. So, as we know, first just take example of factorial. We get just if 4, if this is 4, then this will call 4 into fact 3, then 3 into fact 2, then 2 into fact 1, then 1 into fact 0. So, at last we call the fact 0 this function, and this will return the value, to the its calling function, that is fact 1, that is 1, and release the memory, release from the memory. So, this depict the manner of last in first out, comes in the last and goes release from the memory from first, and then this will calculate 2 into 1, that is 2, and release from the memory, means manner of keeping the or managing the recursion by using stack, last in first out manner. And where a function call another function or itself as callee, the caller function transfer execution control to the callee, we already know. The caller function has to suspend its execution temporarily and resume later when the execution control returns from the callee function. Just here stop its process, simple, and goes for another call fact2, and this stop the process and goes for its calling function for the fact1. So stop the current execution and goes for the its calling function. The caller function need to start exactly from the point of execution where it puts itself on hold. So start at the same point. As we see, this stops from here and transfer its control to the newer call, that is fact1, and after coming control from fact1, same point of return at the same point from where it was called. So this is 2. So same point returning on same point. Another, for this purpose an activation record or stack frame is created for the caller function. So complete stack frame we can see in this picture. This is the stack frame. Now different recursive call, just function n, and another recursive call here fact n minus 1. This will call another call for function fact n minus 2 and approaching to the base case, and so on. So for the first call, activation record is created. In the activation record, there are various parameters associated with this particular function. As which type of information? Local variable, formal parameter, and return address, means or another different parameter for each, means this activation record keeps the different information related to this particular function. These information may be a local variable, formal parameters, and address, returning point, where to return, and for each recursive call maintain this record. In which fashion? In last in first out fashion, means we are using stack. We are using stack here. Okay. So this is very important, how to keep the recursive call in memory. So if we go infinite calling, if we leave the base case or we write incorrectly the base case, then what is the will be the effect? Effect is stack overflow. Stack overflow means how many activation record to keep. Memory has some limit, so this will overflow the stack and program terminate abnormally. So we must care for writing the base case. Now some analysis of recursion. Now the time complexity. What is the time complexity for recursion? So generally time complexity means how much time it will require in terms of n. So for a single call, we just guess this is O1 and we are creating n number of recursive call, so we use On. O means this is the worst case, means assuming everything is constant, we try to figure out the number of times a recursive call is being made. A call made to a function is O1, means constant, hence the n number of times a recursive call is made makes the recursive On. Simple, this is the running time and second complexity term is space. How much space this will required? As we see in the previous slide, space is maintained by the using activation record. So space complexity is counted as what amount of extra space is required for the module to execute. The system need to store the activation record. This is the main, store the activation record. Each time the recursive call is made, n number of recursive call, then there will be n number of activation records. Hence, consider that space complexity of the recursive function go higher than of a function with iteration. Same task, same problem can be solved using iteration, means looping. So this will require, this is the negative point for the recursion, means activation record, too much space is occupied by the recursion, but the simplest logic we can easily write our code if we follow the recursive method. So this is the one negative point, means drawback of recursion. How to overcome this drawback or recursion? Means the number of activation record. So we use the tail recursion concept. Now tail recursion concept, what is tail recursion? In tail recursion we get final output on the base case or tail of the recursion, means we call from here, means if we call just any value, fact 4, this will call fact 3, this will call fact 2, this will call fact 1, okay, and this will call fact 0. This is our base case, and so if we get final output at this point here, we do not need to backward go, we need not to go backward, and we get the final output here. This technique is known as tail recursion. So how to implement this? Now we will see. The tail recursion is basically using the recursive function as the last statement of the function. This is the last statement of the function. We can make function tail recursive by adding one other parameter, that is accumulator, in function signature to pass intermediate result. So how to accomplish this tail recursion, how to get the final output at that base case point? We must pass another parameter intermediate that hold the intermediate result. We are passing intermediate result, and here the final result, and we will get. So one extra parameter is required, one additional parameter is required. Generally we know that parameter as accumulator. Now we will see an example. Just same example, we are going to calculate the factorial of a particular number n by using this particular tail recursion. So we need one extra parameter as accumulator. So this is the default value, that is default value. What is the default value? The base case value. If the n is 0, then this default value will work, okay. Just see here, if the n equals 0, we are returning the value r, okay. So at that particular point of time when n is 0, the value of r will be returned as a final value. So there is no need to backtrack. Otherwise we will return what? We will return two different parameter. We are decreasing, as in the previous example, parameter n minus 1, and we are passing the intermediate result, that is n into r, as the next recursive call. For the next recursive call, as we see here in the picture, this is the driver code, as same driver code, and we are changing only here. We are changing only here these 3 points. Now enter a number, we enter the 4 and get the factorial of 4 is 24. So here no need to create a new stack frame. New stack frame there is no need to create. Now this is the first call. If 4 1 is the first R value, and this will call the fact 3 and 4 decreased by 1, and what is this 4? This is the intermediate result, that is obtained from the 4 into 1, R into n. The value of R is n is 4 and R is 1. So, we for the next call the value of R is 4, and for the next recursive call this decreased 1 and the intermediate result is n into R, n is 3, R is 4. So, for this particular call R is 3 into 4, intermediate result become 12. Now, another call, this is decreased by 1 and this intermediate result is 2 into this n and R is 12, 2 into 12 equal 24. Now, next recursive call we decrease this one 0 and we 1 into 24, that is 24 here. This now we is at the base case. At the base case what we will return? Return the value of R. Now, R is 24. Now, R is 24 and we get the final output here 24 at the base case point. Here the base case is what? When n equal 0, then return this particular R is 24. Here we can see we need not to backtrack, here, we need not to backtrack here. In the previous example we are getting output here, final output here, but in the tail recursion we are getting the final output at the base case. So, there is no need to backtrack. So, there is no need to keep the activation record. Why we keep the activation record? No need to keep the activation record. So, only one function activation record must be there, only one, not an activation record is necessary to keep this particular functions. So, which was the negative point, disadvantage for the recursion, means not efficient, and so we can overcome this problem by using tail recursion. And this tail recursion is language dependent. Some language implement this and some language implement not this. So, we will also consider this in mind. Okay. So, I hope you all understand this recursion concept nicely. Okay, thank you. Thanks a lot.